Okay, let's just double check it's going. All right, it's going this time. Okay, so we have x-axis, y-axis, they cross right at 0. So they cross at 0, 0. We call that the origin. So right here, this point where they cross, its value is 0 for x, 0 for y, and we call that the origin. O-R-I-G-I-N. Origin. Remember, your x values are left to right, your y values are up or down. So you can find, given any two values, a point on the corner of a square. So for example, if we have 3, negative 2, this tells me to go 3 to the right and down 2. So I count from the origin, 1, 2, 3, 1, 2, 3, and then I count negative 2, 1, 2. So I would put a point right in the corner of the grid. Delano, can you pay attention, please? And that would be the corner. Now you can also graph fractions. For example, negative 2.5, comma 3. So I go over 2.5 to the left because it's a negative value. 1, 2.5, up 3. 1, 2, 3. And so now, because I have a fraction, which is like a decimal value, I am not in the corner of the grid. I am on a line in between negative 2 and negative 3. You can graph such things as square root 2 and negative root 9. Now, what about root 2? Where would you put that on a grid? Well, you probably turn into a decimal to help yourself out. 1.4. And then negative 9, root 9 is negative 3. So I go over 1 and a little bit, and then go down 3. And right there would be that value. Okay. You can even have values with 2 decimals, which means you'd be inside a square. You have to crisscross the number line. Okay. We're going to go over that again in a little bit. Okay. The grid is divided into 4 quadrants. The first quadrant starts where we typically graph our science graphs. So you put a Roman numeral 1. At this point, all x values are positive, and what about y values? They're all positive as well. Then it's anti-clockwise. So over here we have the Roman numeral 2 because that's quadrant 2. Our x values now are negative, but our y values are positive. So negative x values, I put a negative sign in the x position and a positive sign in the y position. What quadrant do you think this one is down below, bottom left? Quadrant 3. Okay, quadrant 3. And all the x values here, what do you think they are? Negative. What about all the y values? Negative. Our last quadrant, quadrant 4, Roman numerals say to put an I first and then a V. Now we're on the other side of 0 for our x values, so all our x values are positive, but we're still below the number line, so y values are negative. Okay. So knowing what the values should be in each quadrant can help you check and make sure you graph properly. When you're graphing, start at the origin. Actually put your pencil there and touch it, right here. Then, every point is an ordered pair with brackets and a comma. So the first number tells the number of units to the right, if positive, and to the left, if negative. The second number tells the number of units up, if positive, or down, if negative. So the positive and negative signs indicate directions to count. So let's make a quick little grid here. you can just make two lines crossing. Okay. So first number is a 2. Remember, x is left or right, so it tells us to go 2 units to the right because it's a positive 2. So I count 1, 2. The negative 3, because it's a negative, I have to go down 3. 1, 2, 3. So then I can put a point on the grid and label it with the letter R. Any questions? So what I want you to do now is exercises on the right side of the page. Point A is at negative 3 for my x value, positive 2 for my y value. So that's what I'd write down for the answer. Bracket, negative 3, comma, 2, bracket. You must have the brackets. You must have the comma. Any questions? Okay. Then for the second part, down below, I give you the point. You have to label it on your grid properly. Go ahead, complete that. I'm going to give you 10 minutes. I'll come back at 5 after and we'll go over the answers. If you've done the first page, turn it over to the back and answer the question, what did one ear say to the other? Go. 10 minutes. Actually a bit longer, but go for it. Okay, let's go over this then. Point A. What'd you get, Darm? Good. Negative 3 and 2. Point B. Brian.
Negative 4 and 4.
Good. Point C. Owen.
2, 4.
Good. Point D. Kenya. Good. Point E. Rithik. Good. Point F. Miranda. Good. Point G. Cameron. Good. Point H. Pinto.
-2, -4.
Good. Annika. Point I. Good. Delano.
4 and -4.
Perfect. Okay. Any questions? Does the order matter?
Oh, yes.
Yeah.
Absolutely huge, right? Because the first number is for the letter, and the second number,
Y.
because I asked. Okay. Up here, we're plotting them. Hey, pay attention. Okay, up here, top left, you should have I. What quadrant is I in? Quadrant 2. Okay. Over here, we should have G up the top, at the edge of the grid. Then B is on the line. B is on the y-axis. We call it the y-intercept point. Okay. D, quadrant 1. What's this point on the x-axis?
J.
J. Okay, down below, quadrant 3, we have C and H. And quadrant 4, we have E, F, and then A right on the edge there. Any questions at all? Okay, so then for homework, you're finishing off what did one ear say to the other. What we're going to do now, though, is we're going to continue on. Okay? So, I'm going to hand out your second sheet today.
I only get one birthday every 4 years. I think next year, though.
Oh, you got leap year?
Yeah.
No way, that's cool.
I was almost leaving. And he has a wait.
Yeah, almost woulda, coulda, shoulda. Okay, your mom didn't want you. That's so sad. Oh, now you're clarifying, eh? Yeah, sure. Okay. I wonder if this is going to improve the audio. We'll see. There are two types of data. The first type is discrete data. Discrete data are whole numbers of objects, example, people. Here, you shouldn't really be connecting the dots. So if you have a graph with discrete data, what you should be doing is you just should be putting points on your grid and leaving it like that. However, people all the time go ahead and connect the dots when they shouldn't be. Okay. Now, that being said, though, often you see them doing it wrong, but if there's like large numbers, then you should. Small numbers, no. If you're plotting 5 and 6, and you're plotting people, you've never seen 5.5 people. Ever. Walking around, talking, no. But large numbers, 5,000, 6,000, it makes sense that there's points in between there. So then you would make a line, because there's 5,001, 5,002. It's such large numbers, it makes sense to assume that it's continuous data, okay, and make a line. But from 5 and 6, the numbers are so small, it doesn't make sense to connect the dots. Whereas continuous data, it's reasonable to assume there's points in between, like decimals. So we say the data is continuous. Some examples of continuous data would be like distance. 1.2 meters, 1.3 meters, 1.4 meters. Even centimeters, you can break it down. Money. Money has decimals. It makes sense to have values in between. Volume. Mass. Temperature. Those are all things that you measure, which makes sense that it's continuous data. Time as well. Time can be broken down to smaller increments. Usually discrete data, those will be items. For example, jugs of milk, coffee cups, desks, houses, okay. Cups, desks. Usually it's going to be a whole number. And so then you would not connect the points unless you had very large numbers. However, connecting the points allows us to interpolate and extrapolate using our graphs. So what does interpolate mean? It means finding values in between plotted points. So if we look at this graph, we have our plotted points, but we can interpolate points in between. So for example, a typical question would be at 2.5 minutes, what is the temperature? And so you go to your graph. You would go and find 2.5 minutes, and you take this new device that was just invented. It's really cool. It's called a ruler. Yeah, and you make something called a straight line, and you make it dashed. Dash it all the way up, dot, 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 until you hit the line made from your graph right here. And then you'd make another straight line that's horizontal, so it's flat, all the way across the other axes, and then you would figure out what number that was. Now what would you say? What number do you think that would be? Yeah, approximately 3.5 minutes. Sorry, 3.5 degrees Celsius. So you want to look at the label of the axes, temperature, and of course label your units correctly. Your units should go inside what? How do I know that it's degrees Celsius? Yeah, it says degrees Celsius inside brackets. Notice how there's also a title. So labeling your axes is really important. Now this other graph, it allows us to extrapolate. So our graph line is only this small. Here we have to draw a dashed line. We have to draw an extension. Now this is really cool. Extrapolate has an EX, and so does extension or extend. Interpolate has an IN, and so does in between. Oh, get it? Interpolate, in between. extension, extrapolate. Just checking, because the last class didn't. So once we have this extension that's drawn right here, we have to draw that dashed line. Then we can answer the question. The question being, when will the price be $80? And so we draw our dashed line horizontally flat until we hit our graphed extension, and then we draw it down in that direction, and we say in approximately 5 years. And you've done this before. I mean, you've looked at graphs and just come up with the answers. What we want to do is show the answers by drawing the lines. Okay? What I want you to do now is use that information to answer these 3 questions, A, B, and C. Go. So, what was the plane's approximate altitude at 50 seconds? Here's 50 seconds in between 40 and 50. So you have to notice that you are going up by 20 seconds each time. So 50 seconds will be right here. Straight line up to the graph. Straight line over. And you should say approximately 10 kilometers. Oh, there we go. So 20 seconds up to the line over approximately 10 kilometers. That's what the squiggly line means. It means approximately. So make sure you have the squiggly line there. At what time was the plane's altitude? Approximately 11K. So now you're going the other direction. Find 11K. It's going to be just a bit above 10. Over to the line, straight line down. And you should say approximately 40 seconds. This next question is a good one. Is it appropriate to join the points with a straight line? Yes, because time and altitude are continuous data. Oh, I'm having a spelling issue today. U-O-U-S, data, D-A-T-A. There we go. So time and altitude are continuous, so it makes sense to join with a straight line. Any questions? Okay, turn it over. Do the next one. Go for it. Answer questions A, B, and C. Let's go over it. So, approximately what period of time does a computer have no value? You can't answer that question until you do this. Make a line with the ruler and extend it all the way. Once you've extended it down, make sure it's nice and straight. You can see it approximately 5. So approximately at 5 years, the computer will have no value. When is it worth approximately 200? Draw a dashed line over and then down, approximately 4 years. Okay. Is it appropriate to join the points? Yes, because it's continuous data. Okay. So money is continuous data, time is continuous data. You can break them into smaller increments. They do not have to be whole numbers. Any questions? Yep.
I don't get part C of the questions.
Okay, so what we're looking at is this right here. Continuous data, all right? Continuous data and discrete data. Discrete data, you should not connect the dots. So they're asking you, what kind of data do you have?
Oh,
That's what they're asking you. So if you have both of them are continuous data, then you can connect it and make a line. If you don't have both two pieces of continuous data, you cannot. So if we're graphing like the height of houses, then you would have to have discrete data points because houses are a whole item. Okay? All right. Okay. So what we're going to do is make a little graph. This is going to be the hardest of the hard graphs ever. We're looking at altitude and temperature. Now, which one are you going to measure? Are you going to measure Yeah, you're going to measure temperature. So this would be your y-axis. And then this here would be your x-axis. Now, it's a little bit weird because usually you do measure altitude if you're doing something with time. Our temperature is also going to be weird because it goes into the negatives and then goes into the positives. So what's that going to tell me is that I'm not going to have x right in the middle. Sorry, right on the corner. It's not going to be a typical science type graph. So what we can do is start about here. And then we can have our x-axis as altitude. And that'll be in meters. And then here would be temperature. And that'll be in degrees Celsius. Make sure your units go in brackets. Extremely important to be clear about what you are saying. What kind of title can we give it? Temperature at different altitudes. Okay. Now, what should we go up and down by? Some things that are good to go up and down by are 1s, 2s, 5s, 10s, and 20s. Don't pick something like 3 or 7 or 9. That's too difficult. If you're thinking 9s, use 10s. Okay? Don't go up by 15s. That can be complicated as well. Okay? Keep it simple. So let's go up and down by 2s. So this here would be -2, 0's in the middle, -4, -6, -8, -10. You don't have to label each one. You can if you want. Okay. Then going up, 2, 4, 6, 8, +10, 12, 14. Okay. What do you think we should go up by for the altitude, looking at your numbers? 200s? Yep, 250s. If we go up by hundreds, how many squares would we need? 18. So let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have 30 squares. We have to go up to 1,800 meters. So we're going to divide 1,800 divided by 30 equals 60 meters per square. So we can't go up by anything less than 60. So can we go up by 50s? No. Can we go up by 75s? Would that be kind of weird and hard to do? And so what would be a better number? Going up by 250s? But that's going to really scrunch into a small piece of graph because each square is going to be a lot more than what we need. You don't need to be exact. You don't need to take your grid and match it to your numbers. Your numbers will fit on there fine. You want to try and make your grid as long as possible so your graph looks proper. So I would recommend going up by hundreds. Okay. Always start at 0. So we had 0, 100, 200, 300, 400, 500, 6, 7, 8, 9, 1,000. 11, 12, 13, 14, 1,500, 16, 17, 18, 19, 20, 2,000. Okay. Now, I could have taken temperature and done the same thing, divided it, But this one's a little bit weird with the temperature because you have the negative, so I didn't do that for us. Okay. So now you're going to plot the numbers on the grid. So 350 and 11.4. So find 350. It'll be in between 300 and 400. Then go up to 11.4. So it'll be pretty close to 12. Okay, pretty close to 12, but not there yet. And this one's going to be completely not touching any lines. It should not be touching any lines because it's not a whole number at all. Then 750. Find 750 and plot 5.7. So this is 500, 6, 7, 750, 5.7, 2, 4, 5.7. Then 1,000, 2.1. That'll be really easy, just a little bit above the corner at 1,000. 1,500 and -5 will be easy because that's going to be right in between -4 and -6. Okay, so it's going to be on a line because it's at 1,500, but it won't be on a corner of a square. It'll be right in between. Then 1,800 and -10. Now, if you did this properly, you should see a line. So now we can connect our points. And it should go through, our line should go through all our points. Okay? They'll be a little bit off. You know, just touching the edge of them. That's fine though. It's just approximating. If you want to do it exact, you put it into the computer and it'd do it exact for you. Any questions? So, 3 marks. Label your titles. Titles 1 mark. Label your axes 1 mark. Put units on your axes. Those 3 things are 3 out of 5. Then you have to set up your grid and draw and plot your points for your total of 5 marks a graph. Okay, so for your homework, worksheet, what does one ear say to the other? And page 226, numbers 1 to 17, omit numbers 3 and 12, and you have to make 4 graphs. 3 or 4, I'm not sure how many. Now, if you don't have graph paper at home, I have some here. I'll hole punch it.